Today we're going to be talking about simplifying radicals, okay? So if we have an example like this, 2 square roots of 3 plus 5 square roots of 3. What do you think we're going to do with those? Add them, okay? Yeah, that's exactly what I want you to do because it says that, right? How are we going to add them?
Outside numbers add and the inside number stays the same.
So what is this acting like?
Yeah.
It's like a variable, right? Is it a variable? No, but in this case it's acting like a variable. We combine our 2 and our 5, our numbers in front, and we leave the root alone. Does that make sense? 11 square roots of 3 minus 3 square roots of 3. Is that going to be like the same kind of thing? Where we subtract the numbers on the outside and we leave the variable alone? Is that the same kind of thing? So what do we get? Yeah, 8 square roots of 3, right? Any questions about adding or subtracting? Do I need to do any more of those? You got adding and subtracting okay? All right, so what usually comes next? Multiplying, okay? So there's a couple different ways that problems like this can show up. Here's the first example. 12x squared y times the square root of 5xy. So the square root of 12x squared y times the square root of 5xy. What do you think I'm going to do here? Multiply everything that's on the inside, right? So do what it says. What's 12 times 5? 60. What is x squared times x? X to the third. And what's y times y? Y squared. Is that simplified though? No, now we're going back just to yesterday, right? How do I simplify this? You remember? Yeah, 60 is what? 4 times 15? And if you didn't know that off the top of your head, you could take your calculator and say 60 times 9, or divided by 9, 60 divided by 16, 60 divided by 25, because I know the square roots of those numbers, right? Hopefully you would have started with 4, and it would have worked, right? But remember that you can do that, right? Okay? What do we do if we have 4 and 15? Does something come out and something stay in? What comes out? 2, because I took the square root of 4, right? Now what stays in? 15, because I don't know the square root of 15. Do you? Okay, so we're allowed to not know stuff, right? Okay, what about x to the third? What do I do with that? X squared times x. So what comes out? Just x, right? Because that's the square root of x squared. And what stays in? X. What do I do with y squared? What comes out? What stays in? Does anything stay in? If I took the square root of y squared, I got y. Is there anything left that stays in? Not this time, right? Okay, so that's just our answer. Does that make sense? So this first part is the only new part to you. You just have to know to multiply all the stuff on the inside, and then this is just a reminder of yesterday, right? Okay. All right. What if the problem looked like this? Still a multiplication problem, but it looks way different. God bless you. Square root of 5 times 3 plus 4 square root of 5. What do you think I do here?
Multiply everything by 5 inside the parentheses except for the square root.
So I'm distributing, right? I'm distributing the square root of 5 to each term. What's the square root of 5 times 3? 3 square root of 5. Is that difficult? Okay. What do I do when I have the square root of 5 times 4 times the square root of 5? I have 4 square root of 5 times the square root of 5. What is the square root of 5 times the square root of 5? Think about the rule we just did here. Square root of 25, right? Well, what is the square root of 25? 5. So if I multiply 2 square roots that together that are the same, what am I going to get? Whatever's inside, right? Does that make sense? So what is 5 times 4? 20. Now, earlier they asked about this. What's different in these two? The order, right? Does it matter what comes first, the square root of the number? It does not. Okay? I just want to make sure that you knew that. Is that all right? Okay? There's sometimes it makes a difference what comes first, right? If there's a variable, that usually comes first. And so some of them were like, well, that one should come first because it's acting like a variable. Well, it acted like a variable up here. It's not really acting like a variable here, is it? Okay? Any questions about that? All right, what if it looked like this? 5 minus the square root of 2 times 3 minus the square root of 3. Do you have an idea how you would start this problem? Oh, just distribute, right? The only difference here is there's only one thing multiplied by each. Here we have to distribute to each term, right? The 5 here, and then we have to do the 2 here and here, the square root of 2 here and here, right? So let's start with this. 5 times 3. 15. What about 5 times negative square root of 3? Minus 5 square root of 3, right? Then I have a negative square root of 2 times 3. What do you think that is? Negative 3 square root of 2. And then I have negative square root of 2 times negative square root of 3. Positive square root of 6. Okay. Now what? Combine like terms. Which ones are like terms? Are any of them like terms? Can I combine these two? Only if they're the same number, right? What do I do with this? That's your answer, right? I know it's long. You're going to be okay. Okay? But I can't combine like terms. Combining like terms is absolutely what I would do. But are any of these square roots alike? No. And can I simplify any of these square roots? None of these square roots are like something like up here where I could factor out something that I know the square root of, right? Guys, that's just the answer. Okay? Any questions so far? So we did addition, subtraction, multiplication, division. Okay? Division comes next. So the first problem may look something like this. 385 divided by 33. The square root of 385 divided by 33. Okay? So the first thing you need to know is we don't have fractions inside of roots. Okay? Thinking about what you learned yesterday, does it make sense that I can change it to this? Right? Because we did that with multiplication yesterday, didn't we? We even did it right up here. We just didn't even write it, right? We separated 60 into 4 and 5 and then took the square root of each. So this should make sense to you. And you said it does. Is that correct? Good. Now, the next thing you need to know is we're not allowed to have square roots in the denominator. Can't. Okay? Why? Because there's some crazy mathematician somewhere that was like, this is a rule. It's just not a good idea. We just don't want to. Okay? And by saying crazy mathematician, that's really the same thing, right? Okay? So here's what we're going to do. Okay? We're going to use our brain. So most of us are going to use our brain. Okay? And we are going to multiply this by something that will help us get rid of the square root. Any idea what I can multiply it by to help me get rid of the square root? Itself, right? Isn't that what we did right here? I said square root of 5 times the square root of 5, and that got rid of the square root, didn't it? So I'm going to multiply it by itself. Now, am I choosing to multiply by the square root of 33, and I'm going to do that on every problem that I have a square root in the denominator? Why did I choose the square root of 33? Because this one is the square root of 33, right? So if I multiply the denominator by the square root of 33, what else do I have to multiply by the square root of 33? The numerator. Okay? Now, please understand, I didn't pick a sissy-pansy problem for us to do right here, right? This is a meaty problem. We have a lot of work to do here, don't we? I chose bigger numbers on purpose because I thought you could handle it, okay? So what do I do? What do I get in the numerator? Yeah, you might need your calculator out for today, might you? Yeah? 385 times 33. Oh, this is your light work today? Awesome. That's good to know. 385 times 33. $12,705 divided by what? 33. We did that on purpose, right? We purposely multiplied both numerator and denominator by this denominator to get rid of the square root, didn't we? Okay? Now, are we done?
No.
Probably not. With a number like 12,705, we're probably not done, right? So what are we doing right now? What are we sitting here doing? We're trying to figure out if we can simplify this. How are we doing that?
By going through
Yeah, 12,705 divided by 4. Doesn't work. 12,705 divided by 9. Doesn't work. 12,705 divided by 16. Somebody do 25. Somebody else do 36. Do we need to assign this so everybody knows what to do? Let's start at the back. 16. Lily, did you do 16? Isaiah 25. Sierra 36, Felicia 49, Ethan 64, Abby 81, Caden 100, Kirsten 121, Jake 144, Kalia 169. 16 doesn't work. Does 25 work? No. 36? Does 36 work? No? Okay, 49? No? 64? Does 64 work? No? Okay. Does 81 work? No? Does 100 work? It's if it's divisible by that number, right? Does 121 work? It does, right? So 121 works. And what do I mean by works? What's 12,705 divided by 121? Please do that. Everyone do that in your calculator. 12,705 divided by 121. So this is 121 times 105, right? Now, remember with me real quick, where did I get those numbers that I just assigned to all of you? Those are the squared numbers. Those are numbers that we know the square root of, right? So that's what we're thinking about when we're trying to figure out if I can simplify a radical. Okay? So 12,705 is 121 times 105. Do I know the square root of 121? What is it? 11. So I get 11 times the square root of 105. Now, I'll go ahead and tell you 105 is not divisible by any of those squares. You could try it if you wanted to. I'll just tell you right now it's not. Okay? All divisible by what? 33. Or all divided by 33. Am I done? I would be. Yeah, 11 and 33 are both divisible by the same number, aren't they? What are they both divisible by? 11, right? If I divide both sides by, or both numbers by 11, I get a 1 and a 3. So my final answer is the square root of 105 over 3. You see what I'm saying by I didn't choose a little baby problem, right? We had to have some thought process here. But would you rather me just show you a baby problem, not ever show you any of the hard ones, and let them just show up on your homework? No, I know you don't want that. Okay? Any questions about that? Okay? One more dividing example. One more. Okay? So it could look like this. 4 over 1 plus the square root of 5. 4 over 1 plus the square root of 5. So first of all, tell me the problem.
The square thing.
I have a squared thing in the denominator. We'll go with that. That's fine. A square root, yes, right? I have a square root in the denominator, and that's not allowed. Okay? Up here, the square root was the only thing in the denominator, so I could just multiply by itself and go from there, right? Is the square thing the only thing in the denominator this time? It's not. So what we have to use is something called a conjugate. Okay? It's a conjugate. So look what we're multiplying by. 1 minus the square root of 5. So how did I get the conjugate? So what happened with this number? It's exactly the same. What happened with this number? Exactly the same, but the signs are opposite. Does everybody understand that? Okay? Whatever this number is, it stays. Whatever this number is, the same. Whatever sign this is, you have to choose the opposite sign. Okay? And if I multiply the denominator by that, yeah, I have to multiply the numerator by the exact same thing, right? Because what I'm multiplying this by now is just 1, and I know 1 is not going to change its value, right? What did I multiply by right here? 1, right? Isn't square root of 33 over square root of 33 equal to 1? Anything divided by itself is 1, so I'm not changing the value of this. I'm adjusting where the square roots are, okay? Now, knowing what you know from right up here, what do I do with this? I distribute, right? So what's 1 times 1? 1. Oh, is it okay if I start in the denominator? Yeah, okay. What's 1 times negative square root of 5? Negative square root of 5. What is the square root of 5 times 1? Square root of 5. And then what is square root of 5 times negative square root of 5? Negative 5, right? Because square root of 5 times square root of 5 is, anytime we multiply it by itself, I get what was inside, right? And then a negative and a positive gives me a negative. But guys, look what happens right here. Isn't that 0? Do you see why I use a conjugate now? Because the conjugate is going to get rid of that square root symbol for me. So in the denominator, what I actually end up with?
1 minus 5.
Which is? Negative 4. What do I do with the numerator? I distribute, just like I did on this example right up here, right? Okay, so 4 times 1 and 4 times negative square root of 5. Okay? Any questions so far? So this, I didn't really do anything, I can't really do anything with that right now, right? But now look. What do you notice about all those? Don't they have a common factor? What if this was a 4? Well, that 4 is a bad example here, right? Because if it was a 4, I could take the square root of it. But if it happened to be the same number as all these, like if these are all 3s, could I mess with the 3 inside? No. We can't touch what's inside, only if we can take the square root of it, right? But what can I do with all 3 of these numbers? Take out a common factor, right? What common factor do I want to take out? 4. Okay. Now, do I want to take out a 4 or do I want to take out a negative 4? Because if I take out a 4, what will I be left with in the denominator? A negative 1. Do we really want a negative 1 in the denominator? No, so let's divide out a negative 4. If I divide a negative 4 out of this, what am I left with? Negative 1. If I divide a negative 4 out of this, what am I left with? And if I divide a negative 4 out of this, what am I left with? 1, right? So what is this right here then? My answer. Okay? Any questions? Any questions on adding, subtracting, multiplying, or dividing radicals?